Yes, ma'am.
Yes, ma'am.
Okay. So today we're going to start physics. Till now we were studying about biology, what is life, what is cell, what is plant, what is animal. Now we are going to just drift away, suddenly we're going to take a drift. We are going to put fourth gear and go to physics. So physics and biology, they're different worlds, right? Biology is something that you're going to read about yourself. Physics is something you're going to read about the world. What is world and what is that and everything. And today especially, we're having an important topic. Important in your life as well as important for your exam. Okay. Obviously, they are important for both. So electric current and its effects. So what does mean by electric current? Yes. Correct. Tell me. Come on. What is
Ma'am,
electric
like it's type of a circuit that gives the electric power for electric devices.
Something is running in the home.
Ma'am, electric current is electrons that keep moving and give electricity.
Electrons keep moving. Okay. Anything else?
Ma'am, electricity is an energy
Very good.
which supports to work any object.
Okay. Fine. Fine. So can you imagine a day without electricity?
No,
Can
ma'am.
you imagine one single day without electricity?
Ma'am, we want
No, ma'am.
joining this tuition, ma'am. Ma'am, if there's no electricity, we can't join this tuition.
Yes, that is good, na. Good for you. No need to listen my boring lectures. You can sit home happy. Right. See, Ashwant smiling like, just I
Ma'am,
said the
no, ma'am.
best word in the world. He's smiling a lot. Not Adrit. If there is no electricity, you can easily tell your mom that I won't join classes, ma. I don't have, electric power in my laptop. Right, Adrit? Correct? Correct? Yes. See, he's telling yes. Adrit, what is electric current?
Ma'am, your voice is.
Yes, what is electric current? Adrit.
Yes, ma'am, which gives electricity to other electric devices.
Okay. See the definition. Electric current is something giving electricity to other devices. Okay, where is electricity coming from then?
Ma'am, actually, by the ma'am, like in the roads, we see the
Transformers.
yes, ma'am, transformers.
Transformers is there. That's why electricity is there. Transformers are gonna just transform the electricity from one place to other place. Okay, transformer is not the god who's gonna give you electricity. Transformer is gonna just transform, transfer, not transform, transfer the electricity from one point to other point. So from where transformers get the electricity?
Ma'am, like when I was sixth or fifth, I learned that windmill or is something like that is used to.
Ma'am, even hydroelectricity. Water.
Hydroelectricity.
Yeah, ma'am.
Okay.
Hydroelectricity. Electricity,
Windmill.
windmill.
Okay.
Water is a conductor of electricity. That's it.
Okay.
Yes, ma'am.
Fine.
And even solar panels.
Solar panels. Very good. So these are the sources, sources of current from where we are, getting the current. What is the ultimate source of current in India? I mean, majority, majorly Indians, like Indian government gives us current from which method? Solar power, windmill, or hydro? From which method?
Ma'am, right now in my apartment, they kept on the terrace all solar panels, ma'am.
Okay. So that is now. I'm telling like, what is the current that you're getting from transformers? So do you all aware about thermal power stations?
Ma'am,
Thermal power
means
stations.
heat. Yes, ma'am.
So in India, majorly India is dependent on coal, burning of coal, charcoal for their electric current. In India,
Ma'am, your voice is breaking.
Yes. Yes.
oh my, okay, wait.
Ma'am, you are in mute.
Am I audible now clearly?
Yes,
Yes?
ma'am.
Okay. So, yes, so we will see everything about this. What is electricity? What is electric current? Everything in this chapter. I made this lecture one like that. It will be at most interesting. Physics are basically, they're very boring according to me. But I don't want my kids also to feel the same physics is boring. So I just made this PPT.
Ma'am, physics is interesting, not boring.
Ma'am, physics, chemistry.
Yeah.
Hello, ma'am. Ma'am, you are in mute. Hello, ma'am.
Am I audible, children?
No, ma'am.
Yes. Yes, ma'am.
1 second, no? Wait a minute.
Am I finished nutrition in plants?
Yes, am I audible? Now?
Ma'am.
Okay. So
Yes, ma'am.
I was changing the Wi-Fi, children. So you're telling now my voice was breaking. Okay. So electric current and its effect. So I made the PPT that this lesson will be at most interesting for you and all. Okay. So anyway, and one more thing I'll be telling you, this chapter, consists of problems. We have some word problems will be there in this chapter. We'll be solving some problems. Hope everything is very easy. No, not a
Ma'am, we
issue.
completed nutrition in plants.
Yes, we completed, Hamza.
Ma'am, is this chapter is there in class 7 NCRT book?
Yeah, it is there.
Okay, ma'am.
Okay.
Okay, ma'am.
Okay. Fine. So yes, we are gonna see a short. So we will be seeing the learning objectives. So this lesson is gonna. So this is not like a nutrition and plant lesson. So this lesson is basically physics. So we'll be learning understanding the flow of electric current and learning to draw the basic circuit diagram, not very efficient big circuit diagrams. We'll be learning to draw basic circuit diagrams. We will understand what is the flow of electric current, what is charge, what is electric charge, what is positive charge, what is negative charge, and everything. Okay. And we are going to differentiate like between conventional current and electron flow. What is conventional current and what is electron flow? Will be so the learning objectives is for the whole lesson. Okay. And we are going to see the different types of circuits based on the flow of electricity. First, we will be seeing what is circuit and what is the flow of electron in the circuit and all. And then we will be seeing the different type of circuit, what is different kind of circuits, and what is the flow of how the flow of electricity will be different in the different circuits. Okay. We'll be seeing that, and connections of bulb in a circuit. Those are all like normal activities we'll be seeing. And we'll be distinguishing, I mean, the differentiation between cell and a battery we'll be seeing. And then we will understand the effects of electric current. That is the next part. So from first to fourth point is the first part of this chapter. This chapter is quite big. It may take even 2 to 3 weeks to complete, okay, minimum. So
I
it is a
think
big chapter.
nutrition plant in plants was way big.
It's not very big actually. You know, I included a lot of other stuffs. Whatever we have studied, you know, almost 5 lectures, max, approximately 5 lectures are you can't find anywhere in your book. That will be from outside. So that I have given. So that's why it's way long. But this is whatever your book is, and I'm not following. I am following your NCERT as well as another textbook from another state board. So I felt that comparatively though, that state book was good. So it has good things. So than your NCERT. So I have taken some things from there also. So this chapter is going to be quite big chapter. Anyway, we will be trying to cover them with, I mean, cover and there is no urgency, you know. We have to, this is not a school, this is not a private school, this is not like your school. You have to complete the portion, you have to conduct the test, nothing like that. We will slowly go, not a problem in that. And then this is the first part, distinguish cell and battery. The second part will be, you know, effects of electric current. So, you know, after completing the fourth point, it will be very clear like what is current, what is electricity, what is cell, what is battery, everything will be very, very clear. And then the next part is we have to study now the effect of them. What is the effect of electric current? What are the factors affecting the current, and what is the factors, sorry, what is the effect of the current? What are the things that we get from current, and what are the things that is going to disturb the current? Okay. So applying their knowledge in identifying the components of electric circuits. Components of electric circuits is not a big deal. While drawing circuit, I'll be telling you. And then we'll be finding the difference between different type of circuits. That is again come under the same thing, different kind of circuits, that's fine. And then of course, not at all least, very, very important, we will be doing numerical problems and circuit problems, right? Yes. So
Ma'am, can you give a homework as any experiment?
I'll give, no problem.
Okay, ma'am.
Yes, I'll give. Okay, so clear with the learning objective. These are the things that we are going to cover in this chapter. If you are more interested in any other topic, like how we did in nutrition. So in nutrition in plants lesson, Venus flytrap, those things, a picture plant, or just one paragraph in your book, but we have, you know, made 2 to 3 lectures. We completely studied about Venus flytraps, insectivorous plants. So like that, if you have any extra interest in any of this, no, we will have a separate lecture. We'll talk more about that. That's not a problem. And then, as I told you before, those who have joined new, like Hamza, upcoming subjective test, you will have questions from this chapter also. Okay, not very tough questions, maybe simple questions will be there. Okay, so
So
now
this weekly test will be based on this chapter.
nutrition in plants, complete chapter from lecture 1 to lecture 13, full chapters. I mean, all the lecture you have to study. I mean, PPTs, I'll give only 4 PPTs are there, not a big deal. And everything is already taught in class. So if you're listening the class very well, then it's quite good. No, not at all a problem. You don't even have to prepare. You can easily attempt. Okay. Then you will also have some of the questions from here.
And will you send the PPTs in WhatsApp?
Yes, I will send in WhatsApp, not in WhatsApp. Okay.
Okay, ma'am.
If you want, I'll send in WhatsApp group also, not a problem. Okay. Ready to explore electric current? Yes?
Yes, ma'am.
Okay, fine. Let's go. Okay. Okay, let's start with a wonderful video. I hope the video will be very interesting. Okay. What is in chat? Why is okay? Yeah, something called seminar is there. What to do? Those who are having seminar, they are constantly they are being absent. I don't know what to do and when to conduct and complete the seminar. I cannot wait for the people to complete their seminar, right? I want to go to the next chapter and we have to explore more and more. We have many things to explore. Just we are in second chapter. So yes, shall we start the video? Hamza, I'll tell you the topic later. Okay.
Okay, ma'am.
Shall we start the video?
Yes, ma'am.
Okay.
Innovative Kids presents the invention of
I hope the sound is not coming.
Ma'am, it's so less.
Ma'am, you just took it on.
Okay.
innovative
Mute everyone. Yes.
Ma'am, you can permanently mute everyone.
Okay, I will mute all. Yes. Okay, fine. I muted everyone. Yes. Shall we start?
Yes, ma'am.
Kids presents the invention of light bulb. Thomas Edison inspirational story for kids.
Once upon a time, in a small town called Milan, Ohio, there lived a curious and determined young boy named Thomas Edison from a very young age. Thomas was always fascinated by how things worked. He would spend hours taking apart gadgets and tinkering with machinery, much to the amusement of his family. One day, Thomas's teacher handed him a note to take home. Worried that it was about his constant experiments in the classroom, Thomas hesitantly handed it to his mother. To his surprise, the note contained a message from his teacher praising his curiosity and suggesting that he should explore his love for learning further. Encouraged by his teacher and supported by his parents, Thomas embarked on a lifelong journey of discovery and invention. He started reading books, conducting experiments, and even set up a small laboratory in the basement of his family's home. Thomas was always eager to learn new things and was never afraid to make mistakes. One of Thomas's most significant inventions came when he was working on finding a way to create a long-lasting and practical electric light source. For years, scientists and inventors had been trying to solve this problem, but no one had succeeded. However, Thomas was determined to change that. He experimented tirelessly, trying various materials and designs. Each attempt brought him closer to his goal, but he faced countless failures along the way. People often questioned his sanity, calling him a dreamer or a mad scientist, but Thomas remained undeterred. Finally, after thousands of attempts, Thomas found the perfect combination of materials for his electric light bulb. It was a momentous achievement that would change the world forever. With his invention, Thomas Edison had brought light to the darkness. But Thomas didn't stop there. He continued to innovate and create throughout his life. He improved the design of the phonograph, a device that could record and play back sound, revolutionizing the way people listened to music and audio recordings. Thomas's inventions weren't just limited to the field of electricity. He also developed a motion picture camera, which paved the way for the birth of the film industry. His inventions and innovations touched nearly every aspect of modern life, making him one of the most influential inventors in history. What made Thomas Edison truly special was his perseverance and resilience in the face of failure. He once said, "I have not failed. I've just found 10,000 ways that won't work." Thomas believed that every failure brought him closer to success and viewed setbacks as opportunities to learn and grow. His story teaches us that failure is not something to be afraid of, but rather a stepping stone to success. It reminds us that, with determination, hard work, and a passion for learning, we can achieve great things. So the next time you turn on a light bulb or listen to your favorite song, remember Thomas Edison and his unwavering spirit of innovation. He is an inspiration to us all, reminding us to dream big, think outside the box, and never give up on our ideas.
Thanks for watching Innovative Kids presents.
Yes. The video is over. Everyone watched?
Yep, ma'am.
Yes, ma'am.
So whenever you switch on the light, you should remember whom?
Thomas Edison.
Yes. So the discovery of bulb is made by Thomas Alva Edison. So that was, the big revolutionary step in the world, because before that, people's life cycle will be like, they'll be in the day, they'll be doing all the work. When the dawn comes, when the 6 o'clock or like 6:30 comes, they will stop the works because they cannot do anything. Imagine there is not even a small bulb Okay, we cannot even imagine our life without light. So that kind of light is discovered and given to us, I mean invented and given to us by Thomas Alva Edison. So, in the discovery, sorry, no, it's not a discovery, it's an invention. Okay. So what is the difference between discovery and invention? Do you all know?
Discovery is like how Isaac Newton discovered gravity. Like he knew more about it. Like he researched and gave it a name, a scientific name. And
Ma'am,
Thomas
discover
Alva
means
Edison, he invented it. He created it.
Correct. Yes.
ma'am, discovery means to like to find something, and invention means to make something.
Exactly. Discovery means already existing thing is something is already existed, but no one is aware about that. Some people suddenly go and tell the world like something, see, this is there. That is discovery. Okay. So invention means something is not at all there, was never there, but the person himself, makes that, establishes that, and give to the world. That is the invention. So actually here Thomas Alva Edison invented the light bulb, right? Yes, so I hope that is good video. Everyone learned. So Thomas Alva Edison is the revolutionary. So he created a revolutionary step. That is where electricity, something called as electricity, came into picture, and everyone started thinking about electricity. All the scientists were started working on more and more about electricity, right? Yes. So Thomas Alva Edison's story, that was we saw now. So in 1882, it was a sunset in the west. That miracle happened in New York City. When Thomas Alva Edison gently pushed the switch on 14,000 bulbs in 9,000 houses, suddenly got lighted up. I mean, like that is the first time he invented the bulb. In that video, you would have said that no, he got 10,000 failures, and the 10,000 failures, like so many times he failed. Like every time whenever he failed, he just learns that this thing is wrong. That's why I failed this time. The next time he will be, rectifying that step, and he will be improvising, and finally one day he got success. From the World War, sorry, it was the greatest invention to mankind. As I told you, it was a revolutionary step. It's a great step to the mankind. Discovery of light is something very, so before that people was thinking only sun is an ultimate source of light, nothing else is there. But after that, no, they came after the discovery of, sorry, invention of bulb. It was a miracle. Yes. So many countries you began using electricity for domestic purpose after the invention of that. And 17 years after the
Ma'am,
New
but when my mother was small, she used to say when it was night, used to be completely dark. There used to be no light.
Yes, because see, in the year 1899, only it came to India. Electricity, for the very first time, it came to India only by late 1899. Okay, that is like 19th century it came. 1899 only it came. We got independence around 1947, right? So even though electricity came to India, Indians, like basically everyone cannot use electricity. Obviously, it will be more costly. So even not only in our mother's generation itself, they used to be like they won't switch off all the lights in all the room. No, we are like wherever we go, we switch on the light. We enjoy the light, fan, AC, fridge, everything. It was not like that before. It was
Ma'am,
like only one room will be there. Yes.
ma'am, so it means exactly after 20 years the bulb was invented. After 20 years, it came to India.
Correct. See the time lapse, how India was, very behind of that. I mean, from New York to travel from New York to India, it has like got 20 years. Why is that so? Is also because like today we have a lot of communication things and that and this everything, but before stages it was not there like that. If something happens in New York, we are getting the information in a second in our mobile, right? As a notification, we are now, if you have the mobile in your hand, you know everything whatever happening in whichever part of the world. But before it was not like that. Nothing was there, no electricity, nothing was invented. So it really costed 20 years for India to actually come, electricity to come to India. The Calcutta Electric Supply Corporation Limited commissioned the first thermal power plant in India on 17 April 1899. So first we have got a thermal power plant on India in Calcutta. Okay, that is called as Calcutta Electric Supply Corporation Limited. Only has commissioned in the sense they have taken the order of to make the electricity in India, kind of. Around 1900s, a thermal power station was set up at the Basin Bridge in Madras. So in Chennai, they have set up at Basin Bridge. There is something called Basin Bridge. Thermal power station was set up there in 1900s after that. And then power was distributed to government press, general hospital, electric tramways, and certain residential areas in Madras. Today, electricity is a common household commodity. We don't even care about electricity nowadays, right? Before it was like a miracle. If somebody, if electricity is there in somebody's house, it will be like a miracle for them, right? So this is all about general introduction and motivation of this chapter. You can take about Thomas Alva Edison, about whatever you're studying now. It's like I created these things to to motivate you to dwell into the chapter. So now actually we will be entering into the chapter. Yes, so we have all learned that.
Ma'am, atom is the building structure of everything in life.
Yes, correct. So atom is the smallest particle in the world. It can neither be created nor be destroyed. You cannot create the atom, you cannot destroy the atom, both. So we have learned that all materials are made up of small particles called atoms. Even we are made up of small particles called atoms, right? I don't
Ma'am,
know.
even our cells are made up of atoms.
Yeah, is it right or wrong? We are made up of atoms or not?
Yes, ma'am.
What, ma'am?
Ma'am, is atom made up of electron, neutron, and a photon?
Correct. Atom is a combination of proton, nucleus, electron, neutron. Yes. The center of the atom is called nucleus. As you can see in this diagram.
Ma'am, I think atom looks same like amoeba.
Amoeba.
Yes, ma'am.
Is the atom looking like amoeba, children?
Nope, ma'am.
Yeah. Hamza, how
No,
amoeba?
like kind of, because the circle thing will be in the center.
No, amoeba is different from atom. Okay. So in the coming subjective
Ma'am?
test, I'll be asking you to draw the atom and as well as amoeba structure. You will be
Ma'am?
like, do not get confused.
Ma'am, I
Yes.
have a doubt.
Ma'am,
Yes.
ma'am, is amoeba made out of atoms?
Everything in this world is made up of atom. Yes.
Ma'am, atom is cannot be seen in microscope also, right? So, like,
Yes.
so how did scientists or physicists discover the shape of atom? Because
Very
when
good.
we search Google, I search many times Google atom, like photons, electrons, and neutrons, because I'm interested there. So whenever I search, this particular diagram only enters that point. So I have a doubt how scientists and physicists discovered the shape of atom if it is not seen
Bro,
in
don't go too
microscope.
much inside.
Yeah, that is actually coming under chemistry. But still, I'll tell you. You know one truth, one bitter truth. There is no particular structure of atom discovered till now. There is no particular structure of atom discovered till now. There are lot of theories and controversies on atom. That is, different full chapter. We'll be learning about structure of atom. There is one full chapter in chemistry called as structure of atom. Structure of atom. So in that, the bestest structure of atom we are following is, okay, sorry. The bestest structure of atom we are following is a circle. Here, this is a nucleus. Inside the nucleus, we have positive charge and the electron revolving the nucleus. This is the bestest structure of atom we are following in 21st century. But there are a lot of theories, lot of scientists have proposed this atom look like this only. No,
Ma'am,
atom looks like that.
Ma'am,
Yes.
Google says that the first person to discover atoms is some Greek philosopher. So his name is Democritus. It seems in the 450 BC.
We don't know about, I don't know about who first discovered atom, but according to my subject knowledge, like whatever I studied when I was, 8th standard you may get, or 9th standard you may get the chapter of the structure of atoms. What are all the different theories proposed by different scientists? Some scientists told like atom looks like this. Some scientists told like atom looks like some other shape. Some scientists even told like the protons or the positive charges are the revolving part, electrons are inside. So many theories were proposed by so many scientists, but the best just
Ma'am, also, ma'am, but how did they know that? Like, is it that also a theory that it may contain photon or it may contain neutron or
no,
electron? Is that
atom.
a theory?
The theory is like structure of atom. Everyone knows that there is something called positive charge, there is something called negative charge, there is something called neutral charge or no charge. Okay, everyone know these three terms are there. But the main question mark is what is the structure of that particular thing? What is the structure of an atom? What is that? Everyone was so curious as it cannot be seen through a naked eye. Everyone proposed different theories. It is not a myth. It is not a myth that atom is exist or not. Atom itself doesn't. No, atom is there. By that, how, ma'am, you can also ask me like, how, ma'am, they are proposing a structure. Like, atom will be like this only. How they are telling? So proof should be there. If some random person comes and tells the atom should be like this, we cannot blindly accept. So based on the characteristics also, based on the characteristics of some certain particle only, they will be proposing the atom will be like this, atom will be like that, atom will be like that. They'll be telling. If you want, we will search that in Google.
Ma'am, you said that everything is made out of atoms.
Yeah,
But now, even things are made out of molecules. So even molecules are made out of atoms.
yeah. Group of atom make up molecules. Structure of, and I think all can see my screen.
Ma'am, it means atoms are so small.
What? No,
Ma'am, does
I
it
can't
mean
hear.
like atoms are so small?
Yeah, it is the smallest and the basic particle in the earth. And you cannot, nowadays scientists have started proposing like something more, more smaller than atom is also there. I will be showing you. That is a recent discovery. Particle.
Ma'am, atom is not only present in the earth, right? It's present in sun, everything, right?
Yes, subatomic particles. See, I have told you. Now they have also found like something called subatomic particles, quarks and leptons. See, quarks and leptons are the recent discovery. Quarks, they now before and all they will be telling like atom is the smallest, and after that, no, they have also made subatomic particles. Subatomic particles called quarks and leptons. Now they are telling quarks and leptons are the smallest, not the atoms. Atoms itself made up of quarks and leptons. Like that, they started. So that is about. No, that is about. So yes, don't want
Ma'am,
to divert
atom
or
is present
distract.
everywhere, right?
Everywhere,
Everywhere,
yes.
like
Yeah.
sun, planets, everywhere.
Yes, correct. Because everything is made up of atom, it means like it will be present inside you also. What is atom? Basically, what atom consists of? If you clearly see, they have positive charge, they have negative charge. Do you think that human body is not having any charges?
Ma'am, it does have.
Yeah. So we are also made up of atom. We can accept that theory, right? Because we are
Ma'am,
having
also
charges.
sometimes, ma'am, like when I was like sixth grade, I learned one in NCRT book only. It was written that if you take a comb and you like comb your hair many times, and there are small papers, and you just keep it near the paper will stick it because they're charged. So
Correct.
sometimes our body also gets charged like that.
Yes, we have that experiment. I have given that in the slide. We'll see that. We'll see about that.
I'm
Okay.
also positive charge and negative charge will create electricity, right?
No. Yeah. Positive charge and negative charge. Like positive charge is attracted to negative charge. Like unlike charges attract each other and they make up together. Yes. Flow of
Electricity.
electrons. Yes. Flow of charges. Yes. We'll be seeing the definition of electricity, what is charge, what is positive, what is negative, everything we'll see. Now you should be knowing about like what is atom. You cannot, no, for now you can tell like this is the structure of atom, or else you can also say this is the structure of atom, that whatever I said, this is the structure of atom. Right? So clear with this? The nucleus consists of protons and neutrons. The protons are the positively charged. Neutrons have no charge. They are neutral. That's why they are called as neutrons. Negatively charged electrons revolve around the nucleus. So it is the recent discovery that everyone accepted that yes, this will be the optimal, optimal strategy or optimal way to describe atom is like proton will be inside the nucleus with the neutron charges, and electrons will be revolving around them. This is the latest strategy accepted by all over the world. Electricity is a form of energy that is associated with electric charges that exist inside the atom. So what are the electric charges that is inside the atom?
Protons, electrons,
Protons, electrons.
neutrons.
Neutrons.
Is neutrons coming under charges?
So no.
Why?
Ma'am, because
Neutrons
it is
have no
neutral.
charge.
Yes,
They have
they
no
are
charge.
neutral. They are neutral. They don't have any, they are neutral. You can say they are neutral in a way. For example, I'll be telling you, I'll be giving you one activity now. So there is a ball. Just assume there is a ball. There is three, okay, three positive, 1, 2, 3, okay, wait. 3, 4 negative. Can you tell me, is the ball positively or negatively charged? Yes.
Ma'am, negatively.
Yes. How did you say it is negatively charged?
Ma'am, as the
Because
negative signs are more than positive.
Normal sense of guessing it, right? So I'm telling you, and I'm drawing another ball. One,
Ma'am,
two,
like
yes.
different type of atoms have like different number of protons and neutrons.
No. So there you have an atomic theory also. So it is like you have around first round will have 2 electrons, second round will have 2 power 2, 4 electrons. Third round will have, sorry, third round will have 2 power 3, 8 electrons. Like that, you have a theory. So this would be neutral or positive, you can answer. So have a theory that is all coming under chemistry, not under electricity chapter. Okay. So yes, so this one, if I'm
Ma'am, it
asking
is
you,
neutralized.
yeah, exactly, neutral. See, if I'm telling you something is neutral, doesn't mean that they have zero charge. It not only means that it is having zero charge. It can also be like the charges cancel each other. Right. When positive and negative attract, they become neutralized. So no, they will be like canceling each other. So you can say this is neutralized. No flow of electrons, no flow of electricity is there. In this flow of electricity is there, that is negative. In this flow of electricity is not there, that is it is neutral. There is no flow of electricity because the charges cancel out each other. They have exactly equal number of positive and negative. Okay, this is not there. Again,
ma'am,
yes.
I don't know whether my doubt is like related to the topic, but it's like kind of related. So my doubt is like sometimes you will see that the steel, like the door hangers and all the steel things. So
Mhm.
sometimes it get charged, and we when we touch it, we get a bit like a jerk or a shock like that,
Shock,
like a
yes.
current.
Yes.
So why it is like that?
Because we are a good conductor of electricity. That's why we are conducting the electricity.
No, ma'am. How it is charged? That steel thing is how it is charged. Because the steel materials are generally not they are not they do not produce electricity. How they are charged? When we touch it, we get shock.
Normally, if you get if you touch a pin, you won't get electric charge. I mean, you won't get shock.
Yeah, ma'am. Like when the like it rains heavily and the current touches something like that. I because I got a shock the one time. So this is
You're
jerk shock.
asking me like, you're asking me like, there is a pin, normal safety pin, we can say. And this safety pin, maybe you have kept this safety pin inside a switch box. Okay, for example. For example, you are keeping this pin inside the switch box and you're switching on. Okay, this the electricity will pass from the switch box. I mean, switch box is basically for what purpose? To give electricity, right? So electricity will go into the pin. The pin will of course get the electricity because they are good conductors of electricity. Steel is a good conductor of electricity. Do everyone know that?
Yes, ma'am.
Everyone?
Ma'am, almost all
And
metals
copper
are
is the best
conductors of
conductor, right?
electricity.
What?
Ma'am,
Copper is the
almost
best
all
conductor.
metals are conductors of electricity.
Almost all.
Yes, ma'am, all.
Metals.
All metals. Yes, correct. All metals are almost a good conductor of
On
electricity.
the side of it.
So,
My school teacher said that copper is the best conductor.
that's why we are using copper wires. Right? We are not using steel
Ma'am,
wires. We are
what,
using copper wires. Yes.
what about the tungsten?
Tungsten is also a metal. Maybe tungsten bulb. You have tungsten bulbs. They are also good conductor of
Yes,
electricity. We have tungsten bulbs. Yes. And why Hamza? Sorry, Ashwant is not at all talking.
ma'am, I am talking now.
Okay, sorry. Okay, it's Ashwin. So, Nandi, coming to your doubt. See, so, switch will be on and, good conduct. I mean, the electricity will be passing through the pin, and pin is a good conductor of electricity. Okay. Now, the pin, if you touch pin, obviously you will get the electric shock because the charges from the electric board will be transferred to electric pin. I mean, pin, and the pin is again will be transferring the charges to you. It will be
Ma'am, what
transferring
if we
charges to you.
turn off the switch?
It will
Then
not. It
also
will
we'll get
stop.
shock.
No, it will stop. How you will get shock? Because you're making the switch off. So you're switching off means you're closing the circuit. If you're switching off, it means you're closing the circuit. So if you're closing the
No,
circuit,
ma'am.
it will
For 2
disconnect.
seconds, it will be charged, right? For 2 seconds, it will be charged. 2 or
I mean,
some seconds.
it will not. So see, if you are asking me the same concept, think like you're switching off the light. Okay. Immediately once you switch off, I mean switch box is here, your light will be somewhere up, right? So if you switch on, immediately your light is burning. I mean, you can see the light is on. If you're switching off, immediately the bulb is turned off, right? So how fast it is happening? Same way, it won't prolong. It won't prolong. So once you switch off, you will not get the electric shock, obviously.
Okay, ma'am.
If you're overloading, some cases are there, like if pin is there, if you're overloading the pin with charge, like normally, not like normally giving it, you're overloading them with charge. Overloading means constantly giving them with lot of electric current. If you're overloading it, it cannot, you cannot do these things under room condition. You can do only in the laboratory condition. If you're overloading with charges, then if you touch, you may get the shock. Yes, you may get, because the pin is already overloaded. It want to neutralize itself, so it will convert, I mean, it will transfer the charges from its body to your body once you touch it.
Yeah, ma'am.
Understanding?
Also, one time I was sleeping. Okay, like I was just sleeping. So, my mom came and I just told her to sleep with me. So when she slept with me, I touched her hand. Then I got a shock. I got a big
Yes.
shock.
Yes.
I don't know why. Like,
I'm daily getting that, Siddhant, actually. Because that is because there is some problem in your building. You know what actually happens? There is something called earthing. I don't know how many of you know this earthing.
I
Yeah.
heard,
Okay.
but I don't know.
That is something called earthing. So we will discuss about this earthing tomorrow. Okay?
Ma'am, I
Okay,
have a
ma'am.
doubt.
Yes.
Ma'am, like once a person gets you said that humans are conductors of electricity, and once a person gets an electric shock, does the electric current pass through the body?
Yes. That's why you're getting electric shock.
So, ma'am, where does the electricity end up? Is it just going to stay in your body, or?
Earth. It will go to earth. That's called earthing.
Okay, ma'am.
Correct? Okay.
Ma'am,
Once you get the electric shock, your body will try to send it to the earth.
ma'am, if we wear like plastic or rubber shoes or anything, then we will not get that much electric shock.
No, we won't
Why?
get electric shock. Yes, because they're bad conductors of electric current.
But we are conductors, na ma'am.
But we are having no, we are conductors. You know what? Actually, oh
Ma'am, we
my,
are conductors because
Ma'am,
we are
actually,
our body is
conductors.
filled up of water.
Yeah, we are conductors, Ashwan. We are conductors. But when okay, I'll share the screen. So 1 second.
And the reason
See,
we are
our body is
conductors
there.
is
You
because
are standing
our
in a
body
rubber.
is filled with water.
Yeah, we are filled with water, and also we have a lot of materials, minerals. These things are also conduction of good conductor of electricity. Okay, so when you touch the electricity, you won't get electric shock because this rubber is a bad conductor of electricity. Even though you are a good conductor of electricity, this will oppose the current. This will oppose. This will tell like I don't want. When you are standing in the rubber, you belong to this rubber. I mean, your body, it will be in contact with this rubber, so this it will be like you are also belonging to this rubber. Belonging in the sense like you will not be a different one and the rubber will not be a different one when you get contact with the rubber. So for example, when you are touching the electricity, you are getting shock. But if you are standing on the rubber, means you won't get shock. You are believing that when I tell like if you touch the electricity, you're getting shock. If I am telling like if you stand on the rubber, you won't get electricity, how can you not believe? Right. Are you getting my point?
Yes, ma'am.
The contact makes the sense. You're in contact with the wood, you're in
Ma'am,
contact with the rubber. Yes.
if the electricity would be high from that rubber, what would happen?
No, they are bad conductors. Whatever, how much our big electricity you get, they are conductors. They won't take up the electricity. And there is a specific mechanism behind that. We will be looking that actually that is not your level, that is 9th standard level. But we will be looking if you are so interested, we will look.
Ma'am, I have a doubt.
Now
Ma'am,
we are closing the session. You can ask the doubt, yes.
Ma'am, they say that we should not touch wires, even though the wires have insulating material. But why,
Yes.
ma'am? You're saying like now rubber. If you touch, even it's an insulating material. That's why electricity does not pass through the body. Now with wires, these wires, they say you should not touch the wires, even though they have insulating material, ma'am. They say you can get shocks.
What is an insulator, first of all?
Ma'am, insulators are things which do not allow electricity.
I love the electricity. So, like, who said you that insulators are there in the wire? The insulators are something that is gonna cover up the wire. When you touch insulator, you won't get electric shock, actually, usually. But when the insulators are also broken and the inner copper thin wire is visible outside, and when you touch the copper wire, then only you will get electric shock.
Ma'am, sometimes
mean-
while we are playing in the playground, when we touch the steel thing of the climbing, then why do we get a shock?
Because steel is a conductor of electricity.
Should I
No,
keep?
there's like no electrical charge there.
I will bring Thomas Alva Edison to solve all your doubts. We'll have a general discussion on all these topics. Okay?
Okay, ma'am.
Ma'am is still alive or not?
He's still alive. He'll come every day.
Ma'am,
12
he'll be
p.m.
in the heaven. He'll be in the heaven. We'll call him from the heaven.
Yes, we will call. So
Yes,
bye
ma'am.
for now.
Bye, ma'am. Thank you, ma'am. Have a nice day.
Ma'am, he died in 1931, ma'am, long ago.